Thank you for having me. I've been having some laptop fan issues lately, so I hope there's not too much background noise. If it's not noticeable, then we can just um, move on. But let me know if it becomes a problem.
No worries. We use Schoology every day, so we're used to it.
Okay,
So
awesome.
we're good. Yeah. All right. I gotta shut the mic. That way you guys will have less noise.
Okay.
So, are we ready to start, or should we wait some more? Oh, there's 27. Okay.
Before we start, students, can you guys sign in with the link in the chat? Thank you.
We can't hear you, Mr. Alonso.
Oh, yeah. Mr. Cuenca brought in his students. So we have folks from the biomed section too.
Nice.
So welcome them.
Okay, great.
So
Awesome.
we have quite a diverse group today. Not only robotics, but we also have the biotech guys. So we're good.
Okay, excellent.
So should we wait? We got 27. Should we wait a couple minutes?
Yeah, let me try to put my camera on, but somehow I'm having trouble.
Yeah, I'm gonna turn my mic off because I don't want all that noise. So
Okay.
Somehow it's not working, but anyways.
Mr. Cuenca, you see that on the chat, they put in a link for signing in for the FRC folks. I don't know if you want to have one for your students too. Not sure, but just in case there's a place there that we might want to use for that on the chat.
There's a hostess sign-in link. Feel free to share it, and then we can differentiate between the hostess students and the FRC students for attendance.
Perfect. Thank you. All right. So I guess, Mr. Tran, how long is your presentation about?
It's not terribly long. It's 20 slides, and I tried to leave time for questions and interaction.
Okay, so I think we probably need to get started then. We should.
Okay.
Yeah. So Mr. Peralta, take it from here, please.
Okay. Hi, Mr. Peralta, the lead mentor for Robotics 4079, and welcome to our, excuse me, sorry about that. Well, we have a special guest speaker. His name is David Tran, and he's one of the very special guest speakers here because he's an alumni and was president from our first robotics at Oxford Academy. It used to be started as a robotics club, and we used a platform called Vex Robotics. If anybody's not familiar with that, I know we have some biomed students here, so I welcome them as well. And Mr. David Tran was president of the club, and we kept in touch over the years. And I really wanted him to be a mentor for our team and prove that he can give back to the team as well, because he has a special skill, and I want him to introduce that special skill to you guys. So, and so over the years, we kept in touch, and I think I don't know when was when did you become our mentor? I think it was a couple of years ago or 3 years?
Yeah, I think around 3 years ago.
3 years ago.
Yeah.
So he's has been working on some biomed. He's been working in the field in biomed companies. So he's going to tell you more about it. So take it away, and please welcome Mr. David Tran.
All right. Thank you, Mr. Peralta. I'm happy to be here with you. Let me just give me one moment to try to share screen. Uh-oh. Firefox is not letting me share my screen.
Do you are you going down to present? Is that what
Yeah,
you're trying to do?
present.
What is it telling you?
Oh, man. Okay, just give me 1 second to switch browsers. Okay.
You got it.
All right. So can everyone see the PowerPoint now?
Yes.
Okay, great. All right. So yeah, sorry for that technical difficulty and delay. And thank you again, Mr. Peralta, for the great introduction. As you all know, my name is David Tran. I'm a sterilization specialist working in the medical device industry. And today, as as Mr. Peralta mentioned in his introduction, I did attend Oxford Academy, just like all of you, and um, I'll be talking a little bit about my personal background, what it was like going to Oxford College and beyond, and then try to get into a little bit of quality engineering concepts, because as a sterilization specialist, there aren't many sterilization specialists in the world, so I guess it's a unique opportunity to hear from one, but also I don't expect many of you, if anyone, to become a sterilization specialist, but quality engineering, the broader topic, will affect you no matter where you end up going in the future. So with that, feel free to let me know if you have any questions at any point. Just throw that out there, and I will happily take questions. So to begin with, when I first came to Oxford Academy, way back in 2004, I was a young and innocent 7th grader. I didn't have the very clear idea of how to navigate getting a career in STEM. I had an idea that I liked doing physics, but nothing super specific. I had cluster with Mrs. Jensen. I played trombone in the orchestra and and jazz band. And back then, there was no bioengineering, biomedical pathway. Your only options were either business or health. And health was with, it was geared less towards industry and more towards like, trying to become a doctor or a pharmacist. So I went into the business pathway and graduated in 2010. As Mr. Peralta mentioned, when I was a student, for the first 5 years that I was there weren't really any opportunities to get involved in engineering. There were ways to do business through the business pathway. There were, a lot of different pre-health organizations for all the future doctors. But if you just wanted to do science or engineering, there wasn't really a clear way to pursue that interest. So in 2009, that's when we founded the robotics club. It was just a club back then. The first two mentors, Mr. Peralta and Mr. Wright, have been with us since the beginning. So that's 11 years, going on 12 years now. So I just want to take a moment to thank them for over a decade of support. You guys are really lucky to have them taking the time and continued support to keep this organization going. And back then, the advisor was Mr. Stevens, who I believe is now retired. And we didn't have that many resources in the beginning. We were just a club. We didn't have our own classroom. We didn't have a machine shop. We really had to scrounge together what resources we could find. So we got a cabinet of secondhand tools donated to us. We were able to get some loans from the foundation and a few other contributions, but it was a very, very humble beginning. This picture is of me in a robot costume trying to get students interested in robotics during Club Rush. And yeah, as I mentioned, it's very, very humble beginnings, but we were actually relatively successful from the beginning, even with what limited resources we had. And it's really a great opportunity for all of you, being in it now. I'm glad that it's continued since then. The first year that we did VEX, you can see in this group photo, there's those of us that went on the first competition trip to San Diego to compete in the VEX regionals. And there's our humble little robot on the ground in front of us. The robot for that year, it had two arms that held up kind of a tray that could rotate, which was useful in the game, which was kind of like volleyball, where you would try to dump the balls onto the other side as much as possible, and different shaped balls were worth different amounts of points. So with that design, we could scoop up a bunch of balls to dump on the other side, as well as hold it up as a shield to block the other team. And here's a paparazzi photo of the team from a distance. There you can see Mr. Peralta and Mr. Wright, along with a lot of the other students. And I think it didn't hit me until I was going through old photos to try to find this group photo to put in the presentation. But in terms of getting students involved early to continue on a path into STEM, just from this one group photo, I can tell you that in terms of achieving that mission, this group has been extremely successful. So I could tell you where everyone in this photo is, except for two people. I'm not sure where they just because I haven't kept in touch with those two, but everyone else, we have engineer. Kevin was actually one of the presenters earlier in the series. PhD in economics, science teacher, not sure, engineer, science teacher, Wall Street Journal tech business correspondent, and engineer. So, everyone has gone on to do great things. So after, sorry. I actually can't see if there are any questions. Oh.
If you want, I could read out questions if they come in.
Okay, yeah, if they come up, just let me know.
Yep, I got you.
Okay, cool. Yeah, so feel free anytime to chime in. Yeah, it's been an interesting. It's been really interesting and fulfilling to see the group continue and grow. From 2009 all the way until now, getting new students in, new resources, new people involved. Now you have Dr. Alonso, who's very supportive and helpful as well. There's always a lot going on, and especially with the interesting challenges of this year 2020. Seeing the group still persevere through that and adapt is really inspiring. So, life continued after high school, and I went on to go to undergrad at UC Riverside to study physics. So at that point, I really liked physics in high school, and I wanted to become a physics professor. That was my goal, from high school going into undergrad. So as much as possible, I tried to just eat, breathe, and consume as much physics as possible. But I also got involved in the honors program and some research organizations that kind of focused on presenting research, different undergraduate research to your peers from other majors. And that's been a very, that was a very fulfilling experience. So on the one hand, I participated in research. And if you go to a research university, or even if you don't attend a research university, if you are interested in research and can reach out to a research team, it's a very, very good way of getting hands-on experience while you're in college. Depending on what your goals are, internships are another, you always hear people talk about internships because it's more directly work-related, but research is also just as valuable and teaches just as many life skills and work skills. So I had a intro physics seminar where every week a different professor would come in and just tell us what they did for research. And after one of the professors spoke about these cool two-dimensional materials discovered recently, I just walked up to her after her talk and said, like, hey, that sounds really cool. Would there be any way I can get involved in that? Yeah, sure. Come to the lab, next week for our next meeting. And then I ended up getting involved in two-dimensional materials research for 4 years, which was a really interesting and valuable experience. So the 2D material that I spent most of my time researching was called graphene. Some of you may have heard of it. I believe in 2009 or 2010, the Nobel Prize went to the people that discovered it. So if you have the graphite in your pencil, that's all carbon in many stacks. But if you reduce it to one sheet of atoms, and you just look at that one sheet of atoms, electrons can flow through it in a unique way because they're limited to 2 dimensions instead of 3 dimensions. So in order to study a single layer of atoms, if you want to test the electrical properties of it, for something that you can see and do on a benchtop, you would plug it into some batteries and get your multimeter and measure the voltage across it. But you can't do that for something that's only a few microns wide. So we built nano devices in order to test these materials. So if you see on the bottom right, so it's graphene, the carbon molecules are bonded, as you can see on the bottom left. And on the bottom right, this is one of the nano devices that I had made. The graphene, if you can see, I don't know if my mouse shows up, but in between these two leads right here, that slightly darker magenta is a single layer of carbon atoms. So from one lead to the other lead is roughly 10 microns, or a micron is 1/1,000,000th of a meter. So it's very, very small. A typical human hair is like 70 microns wide. So that would be, filling up this whole screen if we had a human hair on here. So being able to work in a nano device fabrication environment, this picture is me in the clean room where we made these devices. That was a really unique experience, and I learned a lot of hands-on skills that, even though they're not necessarily things that I use on my job on a day-to-day basis today,